Good afternoon, everybody. Today we'll be talking about compaction equipment. In order to understand the compaction of soil and rock, we need to understand the basics of the material design of, or the cross-sectional design of the different layers within a road. So, the backfill is the material used in refilling or cutting other excavation. Then there is also what's called the binder. Then there is another layer called the subbase. Then we have the subgrade. So this terminology, of course, you all know it from the transportation design courses, and we're not interested in designing them, but we are interested in calculating how and calculating the productivity rate of the equipment that will compact these layers. So why do we need compaction? We need compaction mainly to increase the soil strength, decrease the soil settlement, decrease the permeability, and control volumetric changes. Most of the failures that you will see in streets um, in several countries are mainly due to volumetric changes, which is due to bad compaction. So, in order to understand the types of compacting equipment, we need to understand the different methods of compaction. So we have mainly four different methods of compaction. Impact, which is sudden force, or pressure, which means static pressure, static force. Vibration, which is a dynamic vibrating force. And kneading, which is very similar to if you write kneading and here the K is silent. If you look for how people are doing pizzas, maybe you'll find that they do the process of kneading. So they apply, using a roller, they apply a force in going and coming back, and they spread a certain layer. So this is very similar to it. And each technique of these is suitable in some cases for some soils and not suitable for other soils. So for example, cohesionless soils like gravel and sand, they are very poor in compacting by impact, and they could not be compacted by pressure. However, they are very good and they are excellent. They are good and excellent when you are talking about vibration. However, cohesive soils like silt and clay, they are the opposite. So if you use vibration in such a case, you will find a process that's called liquefaction. Soil will start acting as a liquid if you vibrate. However, impact and static pressure are more applicable in such cases. Kneading is applicable for nearly all of them. However, it's because it's a very special thing, and only some types of compactors that we'll be showing you that could apply kneading. In such a case, you need to understand that it's done for a specific purpose that we'll be discussing after. So the major types of compacting equipment, we have the sheep's foot rollers. So this sheep's foot roller, even from its name, you could understand that it has these cubic things in it that looks like the foot of a sheep. And this is a concept that's taken from the Roman civilization, because the Romans were the first to mend roads, and they used sheep to mend the roads. So in modern life, people took the concept of having something like the sheep foot and as steel, and it is added to the roller itself. So now this is done to add more force to it. And if you look at that roller that you could see on right hand side, that roller in specific, you will find that the sheep foot are staggered in it. You're not aligned at one line, they are staggered. So they are staggered on purpose in order to distribute the force in the best way. Very similar to the same concept is stamping rollers. So again, however, the difference is mainly in the dimension and the staggering mode of these tamps. The opposite is the smooth drum compactor, which is in most of the cases could be also vibratory compactors. So it has that additional motor that will apply the vibration itself. So if you could notice here, this vibratory compactor, it is part of the equipment itself. However, if you look at the sheep's foot roller on the left hand side, on the top left hand side, it is an attachment to the tractor. So actually, compactors or rollers, they could be attachment to equipment, or they could be part of the equipment itself. You could find both. Also, we have the pad drum vibratory soil compactors. So now this is a combination between number 2 and number 3. So they got us this hybrid thing, which is number 4, the pad drum vibratory soil compactors. And also you have the pneumatic tire rollers. This pneumatic tire rollers, this is the one that's mainly used in the finishing layer. Okay, and this is the one that works with the kneading process. And by the way, these 5 configurations, these are not the only configurations, but these are the most common that you will be seeing. You will find others for sure, and companies will be designing more and more and more each and every day and enhancing their designs. But these are the 5 basic things that you will be most commonly seeing. So again, if you are combining what we have seen in the previous slide and the one before, you could reach this table that some types of compactors will be working in some modes. So sheep's foot are mainly in pressure. Tamping could be impact, could be pressure. Vibrating compactors are impact and vibration, because typically this motor, it could have 2 different modes, impact and vibration. Pneumatic, it's mainly either pressure or kneading. And from that, we could understand that for each type of material, you have a certain family of compactors that is optimum to use. And from different experiments done, there is a certain range of lift thickness. And the word lift is the layer that you will be compacting. And by the way, that doesn't necessarily mean that this is the whole cross section. So you could have a cross section of maybe 20 inch, but you will divide it into 2 different lifts, because you could not compact it at one stage. You need to compact it at 2 different stages. So the thickness of each stage, the thickness of each stage is called a lift. So this lift thickness, for gravel it ranges from 8 to 12, for sand from 8 to 10 inches. For silt and clay, they are lower in number, but because they are lower in thickness, you will also notice that they need more number of passes. So this could seem unlogic. However, because this is due to the nature of silt and clay. Silt and clay are more difficult to compact than gravel and sand in general. So gravel and sand, if you look at gravel and sand, the number of passes are ranging from 3 to 5. However, for silt, it's from 4 to 8. For clay, it's from 4 to 6. And by saying the number of passes, I'm counting each time as one pass. So Going is one pass, coming back is another pass. So if a compactor goes in one direction, this is one pass. When it comes back, this is another pass. Then it goes again, this is the third pass, comes back, this is the fourth pass, and so on. So we have other types of compacting equipment. So if we look, we have the towed impact compactors, we have the manually operated rammer compactors, we have the manually operated vibratory compactors, we have the compaction wheels, but these are special purpose compactors. So we have here a general rule for roller production estimation. Again, this rule, it's based on the US customer units. So it's mentioning 16.3 times W times S times L times efficiency over N. However, this W is the compacted width in feet. The L is the lift thickness in inches. The S is the roller speed in miles per hour. The N is the number of passes. So you must understand that you should use this formula using these units. Okay, what if we need to use SI units? If you use SI units, it's very simple. You not to have the 16.3 and use consistent units. So remove the 16.3, forget about it, and you will have W in meters, S in meter per hour, L in meter. So now, and efficiency is a ratio, N is a number. So if W is in meter, S in meter per hour, L in meters. So now I'll get meter cube per hour. Very simple, without needing to have this 16.3, without any need to have a conversion factor included. However, this conversion factor, the 16.3 here, is included in that case because I'm using these units that are mentioned in the text. So if we take a nice example, a self-propelled tamping foot compactor will be used to compact a fill being constructed of clay material. Field tests shown that the required density can be achieved with 4 passes. The speed is 3 miles per hour. The thickness is 6 inch. The compacting width is 7 feet. And the bank cubic yards is equal to 0.83 compacted cubic yards. The scraper production estimated for the project is 510 bank cubic yards. How many rollers will be required to maintain this production? Assume 50 minutes per hour. So here I'm having an equipment, the scraper, it's doing the excavation. This excavation or this filling, sorry, is doing the cut and fill. So when it's filling, a compactoring is followed. So you need to match the productivity of both. You don't need the compactor to be faster than the scraper, neither the scraper to be faster than the compactor. So you need to calculate the number of compactors that will do this job in that rate. So simply, I'll calculate the productivity of one compactor. So I'll apply the 16.3 times 7 times 3 times 6 times 50 over 60 divided by 4. This will give us 428 compacted cubic yards per hour. I'll convert the units to banked units by dividing it by 0.83. So now this is 516 bank cubic yards per hour, which is very near to the 510 bank cubic yard per hour, which is the productivity of the scraper that is ahead of the compactor. So this over that, this is approximately 1. So that means that we need only one roller to do this job. That's it for today. And again, please, if you have any questions, insert them in the comments on this video. Thank you.